So let's talk about this intersection graphs. So before starting what or how intersection graphs are made, let's talk about from a perspective of example. It will be very easy to understand. Suppose there are three sets A, B and C. Okay. Now I'm defining this A, writing the A set, say okay. So these are the three sets. What by definition, so I have to make a graph and I have to make a intersection graph from these given sets. Okay, how will I do that? Well, the definition says there will be edge. So basically ABC will be considered as nodes or vertices. Okay, so there will be an edge Eij, say between I and J vertices if and only if ith intersection J set is not phi. Well, there has to be something. Let's see from this example what happens. So, okay, so there are ABC, three nodes. So, how many possible edges can be there? Well, the formula is NC2, where n is the number of vertices, right? This is simple combination theory, right? So this is equals to something n into n minus 1 by 2. Okay, so in this case how many possible edges will be there? 3 into 2 by 2, that is equals to 3. So basically I mean to say there can be three combinations of A, B, B, C, C, A in that way, and that combinations intersection I have to find out. That is what this definition is asking me to do. Let's see. So A intersection B, the result is 2, 3, correct? Then A intersection C, the result is 1, and the result between B and C is left, right? So it has B and C has nothing. So as I discussed from here, okay, from the definition, A and B intersection is not phi, so there will be a edge. A and C is not phi, so there will be an edge. What about B intersection C? B and C, see, there is no intersection value, so that is why here there will be no edge. So this is what intersection graph is.